In this last section, we're going to look at a few examples of how we can put these reactions together. So what we have is something, okay, plus CH3 MgBr in the presence of ether and then acidify H3O plus yields CH3C bond OH bond H bond H. So we have a molecule forming this alcohol. We then add something, and that molecule becomes CH3C bond Cl bond H bond H. So our goal here is to identify the two question marks in this question. So let's look at what we've got. We've got something reacting with CH3MgBr. CH3MgBr is a Grignard reagent. Remember that carbonyl compounds react with Grignard reagents in order to form this. In this case, we have a primary alcohol. The only carbonyl compound that can yield a primary alcohol is formaldehyde. All right, C double bond O bond H bond H. So formaldehyde is capable of reacting with this to form this primary alcohol. We then need to react this compound in order to do a substitution reaction. We've substituted OH for Cl. So we could add HCl or H3O plus NCl minus. Either way, doesn't have to just be HCl, but you need to protonate this and then substitute the chlorine. Because this is a primary alcohol, this is going to undergo an SN2 type of mechanism. Let's look at another example. We have an OH here. I should point out that in these examples, I'm choosing very small molecules, but there may be practical problems, like formaldehyde is a gas. The molecule that you're going to get in the middle here is a gas. So, I'm picking small molecules for simplicity's sake. We don't have to write out a bunch of extra stuff. So we take this molecule, okay, this isopropanol, which is not a gas at room temperature, and we do something to it. And we end up with this molecule. We then do something to this, and we end up with this molecule. So what's the difference? We have a 3-carbon alcohol, and we have a 3-carbon alcohol. The difference is we move the OH from here to here. How can we do that? Well, in the intermediate step, we end up with this alkene. When we have the OH and we end up with the alkene, we need an elimination. Here we have H3O plus, THF, and possibly heat. Okay, you might have to heat this up a little bit in order to get it to go. We got an elimination step in this case. Now, how do we get the OH to add in the anti-Markovnikov way? In that case, we need one BH3 borane and 2 H2O2 in the presence of a base like sodium hydroxide. So this would get this second step to go. Let's look at the last example. In this case, we have CH3, CH2, C double bond O bond H. All right. And we're going to do something to it. All right, two somethings probably is a hint because I put the question mark high so I can write on both sides of this. All right, and that's going to turn this into CH3, CH2, C bond OH bond H bond H, like so. All right, so we get this turning into a primary alcohol. Now we're going to add something to this, and what we're going to end up with, if we add H3O plus and heat, is a ring bonded to a C double bond O bond O CH2 CH2 C, running out of space here, CH3. So we end up with an ester. So let's take a closer look at this. We have an aldehyde forming a primary alcohol. We take a primary alcohol, we add it to something in the presence of H3O plus and heat, and we end up with an ester. So how do we turn an aldehyde into an alcohol? We're going to do a reduction. And the reducing agent that I'm going to use is NaBH4 in ethanol, followed by H3O plus. Now, it wouldn't be wrong to use lithium aluminum hydride and ether to do this reduction, but I'm going to use this example. We now have this alcohol, and we need to add something to it in order to make an ester. Alcohol plus something yields ester. This is a Fischer esterification. And the thing we need to add is a carboxylic acid. That carboxylic acid needs to contain this ring and the C double bond O. So the ring and the C double bond O, but it also needs to be a carboxylic acid, so we put the OH. So if we add these two together, we will make this one. So in just these three examples, we've used, I don't know, half of the reactions that we looked at in this chapter. So basically, practice like this is absolutely essential to make sure you can put these reactions together and understand where they're starting from and where they're going. It's also helpful, as I've been showing the mechanisms, to understand the mechanism, because that can help you to understand where these reactions are taking place, or how these reactions are taking place. And for example, here that the H minus will actually reduce this, because the H minus will attack the carbonyl carbon, and that's this H here, for example, assuming this is the same H, and then this gets protonated by the H3O plus. So I hope that you found this helpful, and this is all the material for this chapter that will be presented in the video lectures.